question at hand involves ground fault circuit interrupter, or GFCI, protection for code-connected engine block heaters in a government facility's parking lot. These heaters are currently powered by GFCI receptacles as per National Electrical Code Section 210.8 B4. The issue is frequent tripping of these GFCIs during overnight hours, leading to cold engines in the morning. The relevant part of Code Section 210.8 B4 requires GFCI protection for receptacles that are accessible to the public. The central question is whether employees in a secure, fenced parking lot are considered the public in the context of the National Electrical Code. Generally, the term public refers to the general public, not specifically to employees. Since the parking lot is secured and fenced, a case could be made that employees using the engine block heaters are not considered accessible to the general public. Therefore, the GFCI requirement may not strictly apply. However, a qualified electrical inspector having jurisdiction should always be consulted for final approval. Assuming you proceed with a modification to the existing GFCI protection, several possible solutions exist to mitigate the nuisance tripping while maintaining safety. One option is to install a time clock to energize the GFCI receptacles during specific overnight hours. This allows the engine block heaters to operate uninterrupted when needed and prevents the GFCIs from tripping due to minor ground faults or leakage current that might occur during periods of high humidity or temperature fluctuations. The time clock should be appropriately rated for the voltage and amperage of the circuit and installed by a qualified electrician following all applicable codes and safety standards. A second option involves installing GFCI protected cord reels mounted on the building's wall. This allows employees to connect extension cords to the cord reel, which then provides the necessary GFCI protection at a single control point. This approach can be beneficial as it centralizes the GFCI protection and potentially reduces the likelihood of individual receptacle trips across the parking lot. The cord rails must be rated for outdoor use and equipped with appropriate weatherproofing to ensure safe and reliable operation in all conditions. A third approach would be to investigate the cause of the GFCI trips. It is possible that the engine block heaters themselves are exhibiting excessive leakage current, which is causing the GFCIs to trip. In this case, replacing or repairing the faulty heaters would be the most effective solution. Each heater should be tested for ground fault leakage using appropriate testing equipment. If the leakage exceeds the GFCI's trip threshold, the heater should be taken out of service. When addressing GFCI nuisance tripping, it's vital to consider the potential safety implications. While removing GFCI protection might seem like a simple solution to prevent tripping, it also removes a crucial safety feature that protects against electrical shock hazards. Therefore, any decision to modify or remove GFCI protection should be made with careful consideration of the risks involved and in consultation with a qualified electrical professional. In selecting the most appropriate solution, it's essential to evaluate the specific circumstances of the installation. Factors to consider include the number of vehicles using engine block heaters, the layout of the parking lot, the available power supply, the local climate conditions, and the budget. A thorough assessment will help you determine the most effective and cost-efficient approach. It is important to understand some of the potential causes of GFCI tripping. GFCIs are designed to detect even very small imbalances in current flow between the hot and neutral conductors. This imbalance can be caused by a ground fault, where current is leaking to ground through a person or an object. However, GFCIs can also trip due to other factors such as capacitive leakage, inductive kickback, or even radio frequency interference. Capacitive leakage can occur when long runs of wiring are installed in conduit or when appliances with electronic components are connected to the circuit. Inductive kickback can occur when motors or other inductive loads are switched on or off. Radio frequency interference can be generated by nearby radio transmitters or other electronic devices. To minimize the likelihood of GFCI tripping, it is important to use high-quality wiring and components to properly ground all equipment and to avoid running long runs of wiring in conduit. It may also be helpful to install surge protectors to protect against voltage spikes and transients. Regarding the National Electrical Code requirements for GFCI protection, Section 210.8 outlines the specific locations and applications where GFCI protection is required for 125-volt, 15 and 20 amp receptacles. These requirements are intended to protect people from electrical shock hazards in areas where they are likely to come into contact with water or other conductive materials. The code specifically requires GFCI protection for receptacles installed in bathrooms, kitchens, garages, outdoors, and other locations. The specific requirements for GFCI protection can be complex and may vary depending on the jurisdiction. Therefore, it is always essential to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years to reflect the latest technological advances and safety practices. The NEC is not a law itself, but it is often adopted by state and local governments as part of their building codes. Compliance with the NEC is essential to ensure the safety of electrical installations and to prevent electrical fires and other hazards. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial. The NEC is a complex and technical document, but it is essential for anyone involved in the design, installation, or maintenance of electrical systems. When working with electrical systems, it is important to follow all safety precautions. Always disconnect power before working on any electrical equipment. Use properly insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. Always assume that electrical equipment is live and take steps to protect yourself from electrical shock. Never work on electrical equipment in wet or damp conditions. If you have any doubts about your ability to safely perform an electrical task, it is best to call a qualified electrician. They have the training and experience to safely handle electrical systems. In addition to the National Electrical Code, there may be other applicable codes and standards that you need to comply with. These may include state or local building codes, as well as industry-specific standards. It is important to research all applicable codes and standards before starting any electrical work. The National Fire Protection Association, or NFPA, is a non-profit organization that develops and publishes codes and standards related to fire safety. The NFPA's codes and standards are widely used in the United States and around the world. The NFPA also provides training and education programs related to fire safety. Their website is a valuable resource for information on fire safety and electrical safety. Another valuable resource for electrical safety information is the Occupational Safety and Health Administration, or OSHA. OSHA is a federal agency that is responsible for ensuring the safety and health of workers in the United States. OSHA has a number of regulations related to electrical safety, which employers are required to comply with. OSHA also provides training and education programs related to electrical safety. Their website is a valuable resource for information on electrical safety in the workplace. When dealing with electrical issues, remember to prioritize safety above all else. Always consult with qualified professionals and adhere to applicable codes and regulations. This ensures the well-being of those using the equipment and the integrity of the electrical system. Addressing the specific issue of engine block heaters, consider the following points. Ensure that the engine block heaters are properly rated for the voltage and amperage of the circuit they are connected to. Using undersized heaters can overload the circuit and cause the GFCI to trip. Inspect the heaters regularly for any signs of damage or deterioration. Damaged heaters can leak current to ground and cause the GFCI to trip. Make sure that the extension cords used to connect the heaters are properly sized and rated for outdoor use. Undersized or damaged extension cords can also cause the GFCI to trip. Consider using heavy-duty extension cords with a waterproof rating. These cords are more resistant to damage and can provide better protection against moisture. Install the receptacles in a location where they are protected from the weather. If the receptacles are exposed to rain or snow, the moisture can cause the GFCI to trip. Consider installing a weatherproof enclosure around the receptacles. Educate employees about the proper use of engine block heaters and extension cords. Employees should be instructed to avoid overloading the circuits and to report any signs of damage or deterioration. Implementing a regular maintenance program for the engine block heaters and receptacles can help to prevent problems and ensure that the system is operating safely and efficiently. The maintenance program should include regular inspections, testing, and repairs. Keep records of all maintenance activities. These records can be helpful in identifying trends and preventing future problems. When troubleshooting GFCI tripping issues, it is helpful to have a basic understanding of how GFCIs work. A GFCI works by monitoring the current flowing through the hot and neutral conductors of a circuit. If there is an imbalance in the current flow, the GFCI will trip and interrupt the circuit. The GFCI is designed to trip very quickly, typically within a few milliseconds, to prevent electrical shock. When a GFCI trips, it is important to determine the cause of the trip before resetting the GFCI. Resetting a GFCI without addressing the underlying problem can be dangerous. To troubleshoot a GFCI trip, start by checking the receptacles and equipment connected to the circuit. Look for any signs of damage or deterioration. If you find any problems, repair or replace the damaged components. If you cannot identify the cause of the trip, you may need to hire a qualified electrician to help you troubleshoot the problem. They have the tools and expertise to safely and effectively diagnose and repair electrical problems. Finally, remember that electrical work can be dangerous. If you are not comfortable working with electricity, it is best to hire a qualified electrician. They have the training and experience to safely handle electrical systems. Always prioritize safety when working with electricity. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals and adhere to applicable codes and regulations when working with electrical systems. This ensures the safety of yourself and others. Ultimately, the decision of whether to remove or modify GFCI protection is a complex one that should be made in consultation with a qualified electrical professional and the authority having jurisdiction. The goal is to find a solution that balances safety with the need for reliable operation of the engine block heaters.